RTX 5090 plus Nemotron 9B on vLLM, benchmarks and TRT-LLM comparison. I've been running Nemotron Nano 9B v2 Japanese on an RTX 5090 with vLLM 0.15.1 and wanted to share some findings that took me a while to figure out, hopefully saves someone else the headache. Benchmarks, RTX 5090, BF16, no quantization. All numbers measured on RTX 5090, 32GB VRAM, running Nemotron Nano 9B v2 Japanese in BF16 precision with no quantization applied. Single request, 83 TOC/S. TTFT, time to first token 45 to 60 milliseconds. Batched, 10 concurrent requests 630 TOC/S. VRAM usage, 30.6/32 GB. Batch throughput is roughly 7.5x single, which is what you'd hope for but nice to confirm empirically. Reasoning parser fix, vLLM 0.15.1. The official Nemotron _Nano _V2 reasoning parser.py plugin from Hugging Face has a broken import path. The original code references. This module doesn't exist in vLLM 0.15.1. The fix. Without this fix, vLLM crashes on startup with module not found error. Max_tokens gotcha. If you enable reasoning and set max_tokens below 1024, you'll get content, null in the response with no obvious error message. The thinking tokens eat up the entire budget before the model can produce an actual answer. Minimum max_tokens, 1024 when reasoning is enabled. Thinking budget control. You can limit thinking tokens to speed up responses without killing quality. At max_thinking_tokens equals 128, I measured Jastor-like accuracy of 0.9/1.0 versus 1.0/1.0 unlimited, a good trade-off for latency-sensitive applications. See the Hugging Face model card for the Thinking Budget client implementation. Why I skipped TRT-LLM. TRT-LLM is genuinely faster in raw throughput, 20 to 100% depending on quantization, and FP8 support is its biggest advantage. But for my setup it didn't make sense. Nemotron uses a Mamba-hybrid architecture, and TRT-LLM's Mamba 2 support is still limited. Without FP8 quantization, I'm staying BF16, the speed gain shrinks to 10-30%. vLLM 0.15.1 batch throughput, 630 TOC/S, is already sufficient for my workload. vLLM's OpenAI-compatible API and Python ecosystem integration is just easier to work with. If you're running a pure transformer model with FP8 on an H100, TRT-LLM probably wins. For Mamba-hybrid on consumer Blackwell hardware at BF16, vLLM is the pragmatic choice right now. Launch command. Mamba_SSM_cache_type float 32 is important, without it, model accuracy degrades.